use Green's theorem to find counterclockwise circulation and outward flux for field F is curve C. We have field F over here and we have curve C over here. We want to begin by graphing the curve. So we have 1. Okay, we have y equals 0, which is this. Y equals 0. We have x equals 1, which is this. X equals 1. And then we have y equals x. Now, we can either find dy dx, which is this, or dx dy, which is this. For this problem, we're going to find dy dx, okay? Begin by figuring out the formula. So the formula is dn over dx minus dm over dy. Now, what is n and what is m? M will be the I component, so this part, and n will be this part. However, since there's a negative here, it's going to be distributed to both of these. Therefore, m is equals x plus y, and n is equals negative x squared minus y squared. Now, in order to find dn over dx, you're going to derive this in terms of x. So you have negative 2x, and y is treated as a constant, dx. Now to find dm dy, you have to treat x as a constant, so you have 1 dy. Now plug these two in, you have this negative 2x dx minus 1 dy. However, we're going to do dy dx, therefore we have negative 2x minus 1 dy dx. Okay, now we have to find the boundaries. So we know what the inside is, which is negative 2x minus 1 dy dx. In order to find the boundaries, you look at this thing, okay? And y is equal to x. Therefore, here, it can only go up here, which is bounded by y equals x. Therefore, x is here. And then the bottom part, it's y equals 0. Therefore, it's bounded by 0. Okay? Now, for dx, you have x equals 1 as the upper boundary. And here, you have this point, which is 0. So this would be your circulation. To find flux, this is equation for circulation. To find flux, it's dm dx plus dn dy. So let's see, what's dm dx? The derivative of m in terms of x is 1 dx. dn dy, the derivative of this in terms of y is 2, no, since we distribute the negative, it would be negative 2y dx. y. Okay, now with these, we could plug it into the equation. So we have dm dx, which is 1 dx, plus dn dy, which is negative 2y dy. But we want to do dy dx. Therefore, we are going to have negative 2y plus 1 dy dx. Our upper boundary would be x, lower boundary would be 0, okay, for dy. For dx, same thing as this, so 0 and 1. This would be your flux.